Now this video is really about absolutely everything that there has ever been, and it's basically talking about the evolution of the universe from the time of the Big Bang up until where we are at the moment. So first of all, if we think about time being equal to zero, this is when for some reason the Big Bang happened and it created all of space and all of time. What was before that? Well, there's nothing. What's the universe expanding into? Well, it's not expanding into anything, there's nothing outside it, it's just making the space. Does that make sense? Not to me it doesn't, but effectively that's where we are at the moment. So basically what we had was almost like an infinitely hot, dense singularity at time equals zero, and this is what we call the Big Bang. Now, we don't really know exactly what happened, our physics doesn't always explain it, and especially not stuff that we're doing at A-level. However, a very, very short amount of time later, so about, in the order of sort of 10 to the minus 43, which is kind of where our physics sort of takes us to at the moment, we know the temperature was about 10 to the 27 Kelvin. I mean, degrees or Kelvin, it doesn't really matter. And basically what we had then was a period called inflation. And this is where there's a really rapid expansion of the universe. Things got a bit weird, like the four forces, the gravitational, electrostatic, strong and weak were all kind of unified. And effectively there's this really rapid period of expansion of the universe. What happened next? At about a time, up until sort of about time of 10 to sort of minus 6 seconds. And here the temperature had started to cool down to about 10 to the 15 Kelvin. What we had now was we had the period where we had basically a sea of quarks in this early universe, these sort of fundamental particles, as well as a load of leptons. So I've got some various electrons and muons and neutrinos here. So basically what we had was basically a sea of quarks, we had leptons, and for some reason, again, my knowledge on this is a bit shaky, but basically we then had things like the Higgs boson, which started to give things mass. But at this point, we didn't have any atoms or anything like that. So, the Higgs boson gives things their mass, and this is the kind of thing that started to sort of come into existence. Now, later on, as time went on, so we're talking now about a time of 10 to the minus 3 seconds. So, just a very short amount of time later. And again, the temperature now started to cool in the region of 10 to the 10 Kelvin. What happened now was that things like the up and the down quarks started to kind of join together. And what we then made were things that we call protons and neutrons. And the thing is, for some reason, as these things started to join together, I'm just going to remove some of these at the moment. What we found was that there were more protons than there were neutrons. So it tended to be a ratio of about 4 protons to 1 neutron. So I'll just move this stuff out of the way. Now something that's worth pointing out is that when this matter was formed, there was approximately the same amount of matter as antimatter that was created, and this is kind of called pair production, where you have high energy gamma rays, and for some reason it causes there to be a matter-antimatter pair. Now this can recombine and then it kind of turns into more energy. But for some reason there is slightly more matter than antimatter made, and that's why we now have the universe, which is made out of matter. So basically, for whatever reason, we have matter, that's where we are, and this is where you had the quarks kind of joining together, and this formed our protons and our neutrons. And again, these are sort of like a sea all sort of flying around, you had electrons and stuff around as well. And what happened over the next sort of 100 seconds or so, so now we're talking about a time equal to about 100 seconds, and you can see how, the temperature keeps dropping as the universe is getting bigger and bigger and the energy is getting more spread out. What we then had was we had certain things forming together. So occasionally we had neutrons and protons joining to make deuterium. We also had a fair amount of helium made. So helium being 2 protons and 2 neutrons. Now this isn't an atom, it's still down at the nuclear scale. And what we had at this point was we had the formation of some of these heavier elements, a small amount of lithium and beryllium. But effectively what we had was basically this made about roughly about 25% of the universe into helium. We had a small amount of lithium and other things, but we still had, over 70% of the universe basically being hydrogen nuclei, which is just these single protons. But the thing is, there's so much energy that every time an electron started to orbit around a proton, it was kind of ripped away again. This is kind of like a really ionized gas, which is what we call a plasma. And it wasn't until the time got to about 100,000 years, where the temperature sort of fell down to about 10 to the 4 Kelvin, that we actually had the combination of basically electrons starting to kind of orbit the protons. What happened then was that we kind of got rid of all of these ions. We then started to have atoms being formed. And the important thing is that when you had atoms being formed, because the whole universe is obviously full of radiation at this point, often this kind of high energy gamma radiation, just packets of energy moving around. As soon as we had this combination of the electrons and protons and the other elements, the universe was then transparent for the gamma radiation to move through. And this is what we call transparency. And this transparency meant that we then had these gamma photons which are moving around, and this is then the origin of our cosmic microwave background radiation. As the universe has expanded, the wavelength has been stretched, and that's made this into microwaves at the moment. So basically, it took a long time, thousands and thousands of years, for the elements that we know, things like hydrogen, things like helium, to form. And it's only when they form together could the gamma rays kind of get through without being kind of absorbed and re-emitted all the time, that we had what we call transparency. So what happened next? Well, we're talking now about 1 million years. And after about 1 million years, this is kind of where the sort of fluctuations in the kind of cosmic microwave background radiation, this shows where we had this kind of large scale structure of the universe forming. So we had, the temperatures kind of dropping down to about 6,000 Kelvin. We have the structure of the universe, we have the kind of early stars forming. And it's in these early stars, which are often quite big and massive, that we had the kind of rapid hydrogen burning, which made the kind of heavier and heavier elements. Where are we now? Well, the time now is about approximately, and it's different numbers depending on the values that we've seen, it's about 14 billion years old. And the temperature now is about 2.7 Kelvin. And this is where we are at the moment. We have galaxies, we have second generation stars, and at some point of all this kind of time of evolution, you're now sitting here watching this video, probably stressing about your exams which are coming up at some point. But hopefully you can see that as time has gone on, as we've got greater and greater time, the temperature has gone down. If we go back in time, we've got a hotter and denser universe. Now basically that is the history of the universe. We started out with, nothing I guess before this. We had this rapid of inflation. Matter and antimatter was created from the energy. It kind of combined and left a bit more matter. And then we had this sea of quarks initially, and sort of leptons. These started to combine to make the protons and the neutrons, which then started to combine together to make the constituents of the early atmosphere, or the early universe, with about 25% hydrogen, and over probably about 75% hydrogen. As time went on, the electrons and protons started to make atoms. The gamma radiation could get through, so it became transparent. And as time went on, we kind of made all the galaxies until here we are today. So that is the history of everything. Thank you.